Hello everybody, my name is Aurelia Claudia and welcome to this video in which I will tell you about polymers in dentistry. But first off, do you know what is polymers? Polymers are large molecules made by joining together repeating of small units called monomers by covalent bonds. The role of polymers in daily life is incredibly important, and one of its functions is to be used as composite resin for white filling in teeth. Composite is a mixture of two different classes of materials. In this case, we are talking about dental composite mixture, which consists polymers, often called resin, and glass particles or fillers. There are two types of polymerization, first being chain growth polymerization, and second being step growth polymerization. Chain growth polymerization is a polymerization technique where unsaturated monomers molecule or molecule with double or triple bonds add onto active site on a growing polymer chain one at a time. On the other hand, step growth polymerization is a polymerization technique that is dependent on multiple condensation reaction or loss of a small molecule from its structure. Maybe you all have noticed that dentists uses dental curing light while performing white fillings with composite resin on patients. Right at that moment when composite resin are cured, polymerization happens inside the mouth. Dental composite resin are converted via free radical polymerization of monomers by either thermal, chemical, or photochemical means. Composite resin based on dimethacrylate monomers. We call it di because there are two methacrylate groups at both ends of the monomers. In free radical polymerization, each molecule grows by addition of a monomer to a terminal free radical reaction site. This categorizes dental composite conversion into chain growth polymerization. During the manufacturing of dental composite, several different types of monomers are used to get the right consistency. The monomers that are commonly used are 1. Bisphenol A diglycidyl dimethacrylate or BisGMA to be short. This is found by Bowen in the late 1950s. BisGMA is very viscous because of the presence of aromatic rings in the structure and also hydrogen bond on the hydroxyl group on the alkyl chain. This brings the structure close together and also cause BisGMA to have low mobility and have higher glass transition temperature or TG. Glass transition temperature is a temperature at which glass converts into rubber. 2. Triethylene glycol dimethacrylate or TEGDMA. This has low viscosity and therefore usually mixed with BisGMA to maintain paste consistency that is suitable for direct application. This also helps to increase amount of cross-linking density in the composite resin paste. Cross-linked polymers are polymer chain that is connected to other polymer chains by covalent bond. This is what makes end product of composite resin rigid. 3. Urethane dimethacrylate or UDMA. The ratios of monomers used in the production of composite resin paste varies depending on manufacturing company and purpose of application. Initiators that can be used are 1. Benzoyl peroxide, which can be split into radical by heat. 2. Azobicysobutyronitrile or AIBN to be short. This can be split into free radical by light. 3. Comfortquinone or alpha diketone, which is commonly used to form free radical by either heat or light. Sometimes co-initiator and accelerator are needed too. They don't absorb light but react with activated initiator to produce free radical and start polymerization. The co-initiator which is commonly used is dimethylaminoethyl methacrylate or DMA-EMA. Reinforcing fillers added can be quartz, colloidal silica, or silica glasses. Fillers add strength, increase modulus elasticity, reduces shrinkage, coefficient thermal, and water absorption. Coupling agent used is gamma-methacryloxypropyl trimethoxysilane, which is used to enhance bonding between filler particles and surrounding polymers matrix. Dental composite is manufactured in two different forms that are self-curing composite and light-curing or photo-curing composite. Both have similar mechanism in which way dental composite resin are converted to rigid solid. Let's talk about self-curing composite first. Self-curing composite is made by mixing two pastes. Let's call it paste A and paste B. Paste A will contain monomers and initiator. Paste B will contain monomer and co-initiator. Polymerization starts when two pastes are mixed. We have seen now that the initiator generated as free radical before. So let's continue to see the rest of the mechanism now. The process of polymerization split into 3 steps. First being initiation, second being propagation, and the last is termination. Comfort-quinone radical move its single electron, and the movement is represented by the single-headed arrow, and an electron move also from the double bond in the bis GMA monomers. The other electron then moved into the carbon next to it. That will give us the compound right here. That will react with other monomers such as TEGDMA and form longer chain. This is called propagation step. It can react with as many monomers that it encounters. So, many lengths of polymer chains are formed. But at one point, it will stop polymerizing and goes to termination. This can happen by reacting with another free radical monomer. How about light-curing composite? It became available in 1970s, and it became more popular because it provides faster completion process. This also allows only one paste to be used, and polymerization just starts when dental composite exposed to light, which gives dentists more time to shape the resin. Light-curing composite consists combination of monomers, light-initiated initiator and co-initiator or activators. The same mechanism occurs, except that this mechanism happens inside the mouth. However, the problem arises from this polymerization. In termination process, not all double bond of all monomer have reacted due to large quantity of bis GMA being used. So, this reduces the mobility of reactive species and probability to react with other monomers randomly. Studies done with infrared spectroscopy claim that a significant percentage of methacrylate groups ranging from 25% to 60% remains unreacted. Reiter and Ozet found out that polymerization by UV visible light only occurs to a certain curing depth, and resin below maximum curing depth was observed to have more unreacted double bonds. Polymerization shrinkage is also another undesired problem. This happened because as covalent bond form, the structure become closer, so the volume decreases. The presence of TEGDMA increases polymerization shrinkage due to its high mobility and therefore higher probability to form bonds. Toxicity of bis GMA, which incorporate bisphenol A group, is also another concern. Some solutions have been suggested to compromise this problem, such as 1. Modification of bis GMA is the other answer to toxicity problem. Hydroxyl group replaced with urethane or methoxy substituents to avoid the hydrogen bond that increase viscosity. 2. Hyperbranch polymers have been used as a solution to shrinkage and viscosity problems since it has low viscosity, low shrinkage, and good mechanical strength. 3. The use of ring opening polymerization reduces shrinkage because this polymerization requires bond breaking for every new bond formation. New monomers are proposed to support this ring opening polymerization, but there are still another problem from one of them new monomer, which increase water uptake, therefore limit the long-term strength of the composite. What's for the future? Improvements rely on researches that are still going on to find the best possible chemical mixture of composite resin. Thank you for watching.